Alright, so in this video I'll finish through 20 and then I'll make a separate video for the last 3 review problems. So let's go ahead and get started here on number 17. Let me fix my mic here. On number 17, we're supposed to find the slope of a line that passes through 2 points. So we have a formula for that. It's called the slope formula. That's that formula there. And so if we're given 2 points, we call those points x1, y1, and x1, 2, or x2, y2, or x sub 2, y sub 2. And all the little subscripts represent is we have our first point and we have our second point. So 9 is, or I should say y sub 2, is just the y value of our second point, which we're calling negative 3, 9 here. It doesn't matter which point you call the first or second point, as long as you're consistent. So here y sub 2, that's going to be 9, minus y sub 1, which is negative 2. So notice we're subtracting a negative there. And then we're going to do x sub 2, which is negative 3, minus x sub 1, which is 5. And so 9 minus negative 2, that's going to be 11, 9 plus 2. And negative 3 minus 5, that's going to be negative 8. And so our answer is negative 11/8. Again, we normally try to keep negatives out of the denominator of a fraction, so we're just moving that negative out front. On number 18, it says determine whether these two lines, or the lines that pass through these points below, are parallel, perpendicular, or neither. So we need to find the slopes. And we know if the slopes are equal, then we have parallel lines. If the slopes are negative reciprocals of each other, they're perpendicular. Otherwise, you would say neither. So for the first line here on part A, our slope is going to be negative 2. Let's see, negative 2 is my y sub 2 minus y sub 1, which is 2. And then negative 1 minus 3, that's going to be x sub 2 minus x sub 1. We're going to end up with negative 4 in the numerator and negative 4 in the denominator. And so that's just 1. For our second line, let's see, we're going to have negative 1 minus 0 over 3 minus 2. And so we're going to get negative 1 in the numerator and 1 in the denominator, so that's negative 1. Now, if you look at these two slopes, they're actually negative reciprocals of each other. It might be helpful. You can write these as 1 over 1 and negative 1 over 1, and you can see that if you flip 1 over 1 and change the sign, you end up with negative 1 over 1. So these are reciprocals of each other, and so these two lines are perpendicular. And that's the symbol you can use if you want to use that to represent perpendicular lines. Let's look at B. So here our slope is going to be negative 2 minus 2, and then negative 5 minus negative 2. So again, we're subtracting a negative there. So we're going to get negative 4 in the numerator, and negative 5 minus negative 2, that's going to be negative 5 plus 2, which is negative 3. And so we're going to get 4/3 here. For the second line, it's going to be 1 minus 4 over negative 3 minus 2. So negative 1 minus 4 is negative 5. And we're going to get negative 5 in the denominator, so we get 1. And these are certainly not perpendicular or parallel, so we would say neither here. All right, on number 19, it says in 2004, the average retail price of 16 ounces of potato chips was $3.35. By 2010, the average price had risen to $4.74. Find the average rate of change in the retail price from 2004 to 2010. Well, we learned in class that when you find an average rate of change, what you're looking for is the slope of a line. So I'm going to use a little picture here to help you see this. I'm going to go ahead and draw a graph. And notice I'm putting the years where we would normally have our x-axis, and I'm putting the amounts, or the cost. Now that's cost in dollars, so the 5 represents $5. So I'm putting that on the y-axis, and that's how we normally do graphs. And in fact, the x-axis is often, or almost, I would say most of the time, is used for time. And whatever we're interested in is often, well, that's what we're going to see on the y-axis. So as we create our points, we want our years to represent an x value and our prices to be y values. I'm going to go ahead and put the points in here. So you don't have to do the graph and all that, but those are the points that you should have come up with. And so let's go ahead and find the, oh, there's the line that we're basically approximating this rate of change using this line that goes through these 2 points. So the rate of change, we said, is equal to the slope, which is the change in y over the change in x. Oops, and I messed that up. I need to fix that. Let me do that real quick. So that was y2 minus y1 over x2 minus x1. All right, so we're going to get, let's see, let's call, those are, we'll label our points that way. So y sub 2 is 4.74 minus y sub 1, which is 335. And then it'll be 210 minus 204, well, 2010 minus 2004. And we're going to get 1.39 over 6. Now, when we give an average rate of change, it's going to be in units, or it's going to be a rate, which is an expression that has 2 different values in it. So in the numerator, notice we have money, because we're talking about dollars and cents there. So let me go ahead and put a dollar sign in there. In the denominator, we're dealing with years. And so when we get our final answer by dividing here, we're going to get 0.23, and that's going to be per year. So that's the amount of money that the price is going up by each year on average during this period of time. All right, let's move on to number 20. So here it says we're going to write a slope-intercept equation. So first of all, remember the slope-intercept form is mx plus b. However, that being said, if we're supposed to write an equation, we want to start with the point-slope form of a line. And so it's point-slope form. We need a point and a slope to use it, and that's what we have here. So my x1, well, my slope is 5, and my x1, y1 is 2, negative 3. And so let's plug in our numbers. And now I've got minus negative 3. I'm going to go ahead and change that to plus 3 before I do anything else. And, oh, it looks like I made another mistake here. That should be minus 10. So let's fix that. And so we're going to get y by itself, we'll have to subtract 3 on both sides. And so again, I'm going to end up with the answer I need to fix here. We'll get 5x minus, and it's not 5, it's actually minus 13. And that's going to be our final answer here. That's what we were asked to find, slope-intercept form. All right, so now let's do the second one here. So again, we're going to want to start with that point-slope form, and that's what we have here. So let's plug in our slope and our point. So you could start distributing, but I highly encourage you to, and you may have already written a y plus 12 and an x plus 4, but don't distribute until you get rid of those double negatives. Otherwise, there's a good chance you'll make a mistake along the way. So now I'm ready to distribute the negative 2/3. So let's move to the right here. So we're going to subtract, well, actually I'm going to go ahead and distribute on the right. The left doesn't change. So negative 2/3 times x is negative 2/3 x. And then I need to multiply negative 2/3 times 4. So let me do that over here. I'm going to write that as 4 over 1. And we'll multiply across. We get 8/3. So when I multiply negative 2/3 times 4, I'm going to get a minus 8/3 because of the signs there. Now I need to get rid of that 12 by subtracting 12 on both sides. So we're going to get y on the left, and on the right side, negative 2/3 x, that's not going to change, but I've got negative 8/3 minus 12. So let me show you, I'm going to do the work up above here. So negative 8/3 minus 12, I need a common denominator to subtract these. And so I need to multiply that 1 by 3. So I'll have to multiply the 12 by 3, and we're going to end up with negative 8/3 minus 36 over 3. So 36 over 3 is still 12, but now I have the denominator I need. So when you subtract negative 8 minus 36, you get negative 44. So we have negative 44/3, and so that's going to be the end of, that's what we're going to get there when we combine minus 8/3 and a minus 12. And that's it for this video. Again, I'll put the review problems at the very end of the review for test 2. Those last 3 problems I'll put on a separate video.